This is an example problem regarding centripetal acceleration and force. We have 150 grams attached to a string. That string is anchored back here at the center at somebody's hand. And the 150 grams is in rotation in a horizontal circle. We're going to ignore the dip that occurs because of gravity on it. Just say it goes in a horizontal circle that has a radius of 80 centimeters. The mass is completing 2 revolutions every second. We want to know a few things. We want to know what is the tension in the thread. We're going to do another calculation where we say that the thread breaks if the tension gets up to 30 newtons or more. And we want to know we want to calculate the maximum speed at that boundary at the time that the tension is 30 newtons. And then when that's the case, what is the number of revolutions per second? How's it compared to the current 2 revolutions per second? So we'll get started on this, and it's always good to make a drawing, a little sketch of the situation, label the data that you have there, so that's what I've done for you. Well, centripetal acceleration is related to force, F equals ma, so the centripetal force is the mass that's in motion around the circle multiplied by the centripetal acceleration. The centripetal acceleration can be calculated if you know the speed, the magnitude of the velocity, and square that and divide by the radius of the circle. So our speed here, our velocity, magnitude of the velocity, meters per second, radius in meters, and we'll get a centripetal acceleration. Our speed, our magnitude, our velocity is found from distance over time. The distance that the object is traveling around this circle divided by the time. Well, the distance is the circumference. And circumference is 2 times the constant pi times the radius. So let's start to plug some of this in. So our speed here, magnitude of the velocity, is going to be 2 because there are 2 revolutions per second. 2 pi r is the distance for 1 revolution, and we're doing this in 1 second. So if you would pause and plug in the numbers to your own calculator, I hope you agree that we come up with the magnitude of the velocity is 10.05 meters per second. And just a side note, this velocity is tangent to the circle. So what's the centripetal acceleration? We now have v, so we can square that and divide by the radius. Again, pause the video and do your own calculation. I came up with 126.3 meters per second squared. That's a sizable acceleration if you recall that the acceleration due to gravity is 9.81, roughly 10 meters per second squared. Here we have something 126 meters per second squared. Well, one more step. Let's find the tension in the string that's creating our centripetal force. So the centripetal force is mass times acceleration. 150 grams becomes 0.15 kilograms. And the centripetal acceleration we just found, I have 18.9 newtons. And just to put that in the English system for context, it's a little bit more than 4 pounds that this thread has to support. Well, we can go a little further. We can suppose that the thread breaks if the tension gets above 30 newtons. What is the maximum speed for this mass if the radius is still the 80 centimeters? Well, remind ourselves, centripetal force is mass times centripetal acceleration. Centripetal acceleration, the speed squared divided by the radius. So we can find the centripetal force, mv squared divided by r. And if I solve this for v squared, so I'm multiplying both sides by radius, dividing both sides by mass, we find that what we want to calculate the speed squared. The speed squared is fc times radius divided by m. Take the square root of both sides, and now I'm putting my desired quantity over on the left. So the square root of v squared just gives us the v, and this tells you to do the square root function on your calculator. We're told that the thread will break when Fc gets up to 30 newtons. That's the borderline case, the boundary that we want to investigate. So we put that in for the F sub c. Radius is still 0.8 meters and our mass 0.15 kilograms, staying with standard metric units here. And I get a V of 12.65 meters per second. I tend to round off to 3 significant figures, so 12.6 meters per second for the speed. What's that mean in terms of revolutions per second? Well, 1 revolution is 2 pi times the radius. That's 5.027 meters. So now we can calculate our revolutions per second by converting units, really. 12.65 times 1 revolution divide by 5.027 meters, so the meters will cancel, and we'll get revolutions per second. And I come up with 2.52 revolutions per second, a little bit faster than part A of the problem. So at this situation, be careful if you're in line with the mass, because the thread is going to break. So I have an annotated list of my YouTube videos you can access at my website, very simple website, gpclements.com. All the content's free. You don't register. You don't give me your email address, phone number, nothing. Just use it to help you find some more of my YouTube videos and hopefully advance your learning, physics and astronomy, and there's some other subjects there as well. And ask your instructor if you have questions.